Hi everyone, welcome to the Tableau Consultant Certification Exam Preparation and Question Series. My name is Akash. I will explain 10 questions in each video in this series. Let's start with the questions. Question 1. A Tableau workbook is experiencing slow performance due to complex calculation involving multiple nested if-then statements. What is the best approach to optimize this calculation? Here the answer is replace nested if-then statement with the case statement, as case statement can simplify the logic and improve performance, and case statements are generally more efficient. That's why option C is correct. If you see option first, it's saying use a string comparison instead of a numerical comparison, but a string comparison are generally more resource intensive than numerical comparison, so this option is not correct. Option second is saying increase the data source refresh interval, but increasing the data source refresh interval does not address the complexity of a calculation, so this option is incorrect. Option 4 is saying add more filters to reduce the data size. Yes, adding more filters may reduce the data size but does not optimize the calculation logic. So option C is correct. Moving to the next question. A Tableau dashboard uses level of details expression to calculate sales performance by region and product category. The dashboard is performing slowly. What strategy should be used to improve performance? Here answer is option A. Simplify the LOD expression by using aggregated data. So by using aggregate data, surely can reduce the computational load on the Tableau and improve the performance. So this option is correct. If you check option B, replace LOD expression with the string comparison. So string comparison are not suitable for the replacement of the LOD expression, and those already are less efficient. So this option is incorrect. Moving to the option C, increase the server cache size. So it will may help with the general performance but does not specifically optimize LOD expression. Option D is saying use nested if then statement instead of LOD expressions. Actually, nested if then statements are less efficient than LOD expression for complex aggregation. That's why option A is the preferable answer for this question. Moving to the next question. A Tableau consultant is working with the large dataset that includes complex calculations such as extensive string manipulations and multi-level aggregation. To optimize performance, where should this calculation be performed? So here answer is option B, in the data source, example SQL database, before importing into Tableau. So yes, if you have multi-level aggregations or string manipulation, you can perform those calculation in the database itself to reduce the computational load on a Tableau. And if you see first option within a Tableau as a calculated field, it will drastically increase the load on the Tableau. So this will not recommended to perform all the or to create all the calculations as a calculated field. If you see option 3, using Tableau Prep Builder after importing the data into Tableau. Yes, but it will decrease the load on the Tableau, but the data source level calculation will be more efficient in this case. And if you see in Excel before importing the data into Tableau, this is not ideal for the large data set and complex manipulation compared to the database. So option B is correct. In the data source, you can perform multi-level aggregation and string manipulation. Going to the next question. A dashboard is experiencing slow load times due to numerous conditional logic calculation, if then statements within a Tableau. What is the best strategy to improve performance? Here answer is option C. Perform the conditional logic calculation in the database before importing the data into Tableau. Yes, we already discussed this. Before importing the data into Tableau, you can perform all the conditional logic calculation or row level calculation in the database itself to reduce the load on the Tableau. And option A is saying use more filters in a Tableau to reduce the dataset size. Yes, it will reduce the dataset size, but it will not impact the overloading on the Tableau. Option B is saying increase the memory allocation for a Tableau. Increasing the memory allocation can help to some extent but does not address the root cause of the slow performance. It is because of the your logic, right? So option B is not perfectly fine for this answer. Going to option D, create a separate Tableau extract for each calculation. This is not uh, this is not necessarily improve the this is not advisable actually, as creating separate Tableau extract for each calculation can be a long-term process and does not necessarily improve performance as efficiently moving calculation upstream, as we are doing the calculation in a Tableau itself. So this is not a favorable solution. Moving to the question number 5. A Tableau consultant is experiencing slow dashboard performance and decide to use the performance recorder to diagnose the issue. The performance recorder indicates that the most of the time is spent on a computing layout. What should the consultant do to resolve this issue? Here answer is simplify the dashboard layout by reducing the number of sheets and containers. So computing layout time, making it easier. So it's like a, you need to simplify your dashboard to render your dashboard efficiently. If you have a less number of sheets on your dashboard will render smoothly and fastly. So the option B is saying increase the data extract reference frequency. So it not does not address the layout computational issue because it's not related to that. Option C is saying use more complex filter to narrow down the data. Yes, if you are using a more complex filters, it may further slow down the performance and does not resolve the layout issue, as the using complex filter will increase the computational load on the Tableau and it will render slowly. So this option is again incorrect. Going to the option number D, change the data source to faster server may improve the data retrieval time but does not directly affect the layout computation. So our first option is correct. Simplify the dashboard layout by reducing the number of sheets and containers. Moving to the next question. A Tableau user runs a performance recording and identifies that a significant amount of time is spent on executing query. What action should the user take to improve performance? Here, correct answer is option D. Optimize the data source by creating indexes on a frequently queried columns. So if your data source is already indexed or you have already created the indexes on a frequently queried columns, can significantly reduce your query execution time and improving overall performance, as indexing will work in every query, right? And that's why option D is correct. If you check option A, add more complex calculated fields to the workbook, it will increase the query execution time. It will not decrease but it will increase. That's why option A is incorrect. If you check for the option number B, reduce the caching setting on a Tableau server. So if you reduce the caching setting on the Tableau server, it will negatively impact on the performance by increasing data retrieval time. So it will take more time to retrieve the data if you reduce the caching setting, right? So that's why this is not favorable. Option C, increase the number of visualization in the dashboard. It will slow down the performance because of the rendering issue, but it will not help in a executing query issue. So option D is correct. Moving to the next question. A Tableau dashboard is experiencing slow performance due to having a large number of sheets and filters. What is the best approach to improve the performance? So your answer is B. Reduce the number of sheets and combine related information into fewer sheets. As reducing, as we already discussed, reducing the number of sheets and filters, it will increase your rendering time and optimize the dashboard, and it will reduce the computational load on the dashboard. That's why option B is correct. Increase the size of the images used in the dashboard, it will negatively impact on the performance by consuming more memory. So this option is not correct. Add more filters to further narrow down the data. Adding more filters can negatively impact on the performance and increase the processing time. So this is not correct. Use higher resolution image to visual clarity. If you use a higher resolution image, it will increase the file size and can slow down the performance. So only option B is correct. Reduce the number of sheets and combine related information into fewer sheets. That will reduce the rendering time and increase the performance. Moving to the next question. A Tableau workbook is slow to load because it includes several high resolution images. What is the most effective way to resolve this performance issue? Here option C is correct. Replace the high resolution image with optimized and lower resolution version. It will reduce the load time and improve the performance without removing visual elements entirely. Yes, it will give effect of the low resolution version, but it will reduce the impact uh, on the load time, right? If you see the remove the image entirely, so if removing the image entirely not desirable, if they are important for the dashboard presentation, then removing images from the dashboard are not favorable in this case. Moving to the second option, increase the Tableau server cache. Increasing the Tableau server cache will does not directly address this image performance sorry high resolution images issue. This is not correct option. Add more filters to the dashboard to reduce the data size. Adding more filter will reduce the data size, but it will affect the performance and it will not address the issue related to the image size. Moving to the next question. A Tableau consultant needs to create a calculation that shows the average sales per region and per product category. What aggregation function should be used in a combination with the dimensions to achieve this? Here option D is correct. If you use average of sales, this will calculate the average of sales per region and product category as required, right? And option A, sum of sales divided by count of sales. This formula divides the total sales by the count of sales record, which is not the correct method for calculating average sales per dimensions. And if you go with the window average sum of sales, this is this will take average over the window of data which may not align with the requirement and this attribute of sales. So it will return a single value if all records have a same value, but if there are a different value, it will return the asterisks if they do not have the suitable for calculating averages. So option D is correct, averaging sales. Going to the question 10. A business wants to see the total sales for each product category within each region. They need to implement a calculation that includes aggregations and dimensions. Which calculation best achieve this? So here option C is the correct option, sum of sales. Sum of sale in a combination with the dimension of a product and product category and region will aggregate the total sales for each combination of this dimension. So this option is correct. If you choose the window sum in sum of sales, it will be aggregate the data for the specific window which is unnecessary for this scenario. And if we use a total sum of sales, total can be used for the table calculation but is not necessary for a simple calculation with the dimensions. So this option is not correct. And if you use this option, sum of sales divided by count of sales, this formula calculates the average sales but not the total sales per dimension. So sum of sales is the correct option. So thank you guys. I will post more video and more question in this series, and do subscribe for more such contents. Thank you.